Well, good morning for me and afternoon and evening for some others, and I'm really glad that you could join us today. And again, we're going to be talking about modern SQL Server features that make your life better as a data professional. I want to start off just with a word of thanks to the New Stars of Data team, as well as my mentor, Leslie Andrews, who helped me put the slide deck together and gave some feedback on how to get prepared for this event. A slide about me. I started my IT career in February 2008, and at that time I was a administrator for a line of business application in the physical security industry. So think about ADT security, only much smaller. And after I became the administrator of that application, I realized that, hey, there's this thing called SQL Server under there. And I began teaching myself T-SQL. I dove into SQL Server reporting services because, as most of us experience, applications don't all come with the reports that we want. And so that was an interesting and learning experience for me. I also learned transactional replication because that was part of what the application was doing under the covers to provide a warm standby. And so that was just my initial introduction into IT. I officially became a database administrator by title in 2014. I blog at leemarkum.com, and you can reach me on Twitter or the email there, liam@leemarkum.com. I want to set some expectations. This presentation can't go in depth on all the categories and features that I'm going to talk about. Each one of those categories could be whole presentations, and some of the features could be entire presentations in and of themselves. So I'm going to try to give you an introductory discussion of it just to get you started. I am going to talk about just features in the database engine and not integration services, reporting services, or analysis services. I don't work in those areas anymore, and so I want to stick to the database engine because that's what I know. Even though I'm limiting myself just to the database engine, there are a lot of features I could have chosen, and if I left your favorite feature out, just understand I only have an hour. So the agenda today is we're going to touch on the following categories of features so that you can see how modern SQL Server features are going to simplify or improve your experience as a data professional. We're going to look at some things in the category of performance and troubleshooting, things that help you figure out what happened to your data. We're going to look at a category of permissions where you can simplify how you give certain permissions. There have been a lot of T-SQL enhancements over the years, and so we're going to take a look at those. And then last, we're going to look at high availability and disaster recovery and new features in newer versions of SQL Server. So how did I decide which SQL Server versions I was going to discuss? Well, one of my favorite websites, or a website I frequent, is SQLServerUpdates.com. And I go there to get information about what is the latest cumulative update, what is in it, but it also gives you information about the end of life support for that particular cumulative update or whatever it is that I'm searching at the time. Extended support ends for SQL Server 2012, according to that site, in July of 2022. So you have less than a year to still get security patches for SQL Server 2012. 2014, you have about 3 years of support left for security patching. So my encouragement to you is try to get your environments up to at least SQL Server 2014 so that you have some support left. And so because of that, I am typically going to look at features that start in SQL Server 2014 and above. There are a couple of exceptions, and the reason for those exceptions is that those features continue to receive enhancements in later SQL Server versions. So this first category of features that we're going to discuss is this performance category. So let's go ahead and get into that. Intelligent query processing is not a single feature actually, but a collection of new database engine features, some of which started in SQL Server 2014 and have continued to get enhancements in later versions. So there are things like adaptive joins, batch mode, and many other features, but I want to focus and talk about just memory grant feedback for this moment. When SQL Server receives a query from an application, or you as an end user in SQL Server Management Studio, it has to estimate the amount of memory that it needs in order to execute that query. And as the execution progresses, sometimes it has underestimated the number of rows that are going to be produced by a query. And when that happens, there's a spill to temp DB because the rows won't all fit in the memory that's been allotted. When that spill to temp DB occurs, then you have a performance hit because of that. And what memory grant feedback does in SQL Server 2019 is the next time that query runs, it recognizes that query and it says, oh wait, this last time we spilled to temp DB, so I'm going to give this query more memory. And that's a great thing that's going to help performance. You won't have the spill to temp DB. It does also work in reverse. So if it gave too much memory to a query the first time and realizes, oh, the query doesn't need that much, the next time it sees it, it will dial back the query memory or the memory that it granted to that particular query. So in that way, intelligent query processing just under the covers gives you some things that make your performance better. So let's look next at lightweight query profiling. To understand this feature, I really feel like we need to compare or contrast it to what came before, which is called the standard profiling infrastructure. In previous versions of SQL Server, row count information per operator per thread was available using features from this standard profiling infrastructure. And that infrastructure was turned on when you in a session would turn on things like set statistics profile on or set statistics XML. And when you did that, it enables the standard profiling infrastructure. The catch here is that when you use that, you have to have already captured the queries that you're interested in investigating, and then turn these features on and then run your query. So when you have that set up, then you might then run your query that you want to investigate and then look at sys.dmexec query profiles to see the row operator information. You can also capture execution plans using query post execution show plan event in an already running extended event session. However, this standard infrastructure really Microsoft felt like had a bigger impact than they intended. And so they created this lightweight query profiling. And a main difference between standard and lightweight query profiling is that lightweight doesn't capture CPU and I/O information. And the other significant difference is that, at least in SQL Server 2019, it's just on by default. You don't have to, ahead of time, capture the query you want to investigate, then turn some things on, and then run the queries that you want to investigate. So let's see a demo of this feature that helps us answer the question, should I kill this query? And this particular demo comes from GitHub code made available from Bob Ward and related to his book, SQL Server 2019 Revealed. So I've already done some setup here that is that's in Bob Ward's setup from the GitHub. We're just going to run this query to create a long running query. And over in another window while that's running, we will run this query that has a new function in, or new DMV in SQL Server 2016, the sys.dmexec query statistics XML. So you can see that this query is burning up some CPU time, some logical reads, and we have this async network I/O. And as I refresh this, CPU time, logical reads just keeps climbing and climbing. So this is a query that's chewing up a fair amount of resources, and that particular wait type is an indication that SQL Server is waiting on the client to display results. So this might be one indication that you have a query that you might want to kill. If you look at the show plan XML and you hover over the different parts of it, you can see an actual number of rows and estimated number of rows. And this information is as of the time that you last ran this. So each time I run this, I get a refreshed query plan with refreshed information about the rows that have been processed so far. However, we do have this new DMV, sys.dmexec query profiles. So let's take a look and see what that is going to give us. In this result set, you can see that we have a table spool and nested loops operators that have a very, very large estimated row count. And you can see how many rows that have been returned by that operator so far. If we continue executing, that row count column continues to climb for the table spool and nested loops, but as you can see, we're going to be sitting here a while if we're going to wait to see if this query is ever going to finish. So this is a great way to identify queries that you know are going to be long running and that you might want to go ahead and stop before it continues to chew up resources on your SQL Server. So let's go ahead and get back to the presentation. Again, lightweight query profiling is enabled by default in SQL Server 2019. You can turn it on with trace flags in SQL Server 2016 and 2017. Another great performance feature that comes in modern SQL servers that's going to make your life better is Query Store. A Query Store actually solved the challenge of persisting performance data over time. Prior to Query Store, there was a feature called Management Data Warehouse in SQL Server, and you can still turn that on. It's still there, but Query Store is definitely superior to Management Data Warehouse in my experience. I feel like Query Store is easier to turn on, and it has a lot less management that's needed with it, unlike what I experienced when I was trying to use the Management Data Warehouse. Outside of Management Data Warehouse, you had to have things like a server-side trace collecting data, or later you could use extended event sessions capturing performance. These methods, however, but particularly server-side trace, left some significant overhead on the system, especially if you were trying to collect something like query plans. You could also do things like record the output of Atom Mechanics SP who is active to a database. However, I really don't think any of these approaches gives you the kind of insight that Query Store will provide you out of the box. And all of these previously mentioned options are really things that you would have to manage on a regular basis or put a fair amount of effort into in terms of just setting it up and being sure that you're capturing the information that you want. So I really feel like Query Store makes your life better simply by freeing you from having to create and manage your own monitoring processes or, convince your boss to buy a third-party product. Now, Query Store certainly doesn't do everything that third-party products do, but it is a great starting place that's built into SQL Server. So you can get an overview of Query Store at that bit.ly link, which goes to a blog post on my site. Erin Salato came to the St. Charles SQL Server meetup that I co-host, and her presentation is there on YouTube, and she will go into a lot of detail about how to set it up, how it works, and what information you get from it. So those are some resources you can look at after. So Query Store stores your query runtime performance from a lot of different angles, such as the CPU, logical reads, and other metrics that we're going to see in a demo in a few minutes. Initially, it did not collect weight stats information or information by weight category, but in SQL Server 2017 and above, you do get that now by default. SQL Server 2019 has some additional knobs and buttons, and you can set up some custom capture policies to give yourself some better control. Go ahead and take a look at Query Store. Query Store is inside the database. And here's the Query Store folder. So you can drill down into that and you have a bunch of canned reports that exist. I'm just going to look at top resource consuming queries for the moment. By default, you do get the last hour of information for the runtime. You can change this over in the right-hand corner in the configure button. So here's the time interval. You have lots of different options. You can even do custom, where you can go back to different days and see what performance was like. So I'm just going to go back a month and hit apply and OK here in a moment, but I do want to draw your attention to the different kinds of criteria that you can look at: CPU time, degree of parallelism, physical reads, and then once you set that, you can then also adjust for what you want to see in terms of the average, min, or max. I'm just going to leave it on duration for the time being. So this is a great graphical representation of your performance inside this database or for queries that originated from this database. It's really easy to see that this query is the problem child. As I hover over it, you can get kind of a thumbnail of the query itself. You can see that this month I ran it 17 times and it has one plan, which you can see down here in the bottom. This is the estimated plan. It doesn't have the runtime statistics with it. In this quadrant, you can see the various runtimes. You can see if you hover over it, it gives you execution count. You can see the average duration for each of those executions. So let's look at query weight statistics. Again, each time you open a report, it does default to the last hour. I'm going to go ahead and adjust that, just so I can show you a little more information. Again, you have these nice graphs that show you what the weight categories are that have been collected within your SQL Server. If you look at this, you can see, again, average, min, max information. If I double click this, then you can see the queries that are contributing to that weight. And this, again, was the same query that we looked at last time. In order to get back, because maybe you're not as interested in this or you saw several that you want to look at, you just hit this button, it says go back to query weight statistics. And you can dive into parallelism. This query has been the big spender, so to speak. And you can see that you have multiple plans that have occurred. So one thing that you can do within Query Store is hold down Shift and left click. And then right here is a little button that allows you to compare the plans that you have selected. So if I hit this, it opens up in a new window. And this is great if you have an issue like, or you suspect you have parameter sniffing, because this might show you that the shape of the plans is actually different because you're getting different operators. In this case, that isn't what's happening, but you still get information about what's different. This is the top plan. This column here on the right side of the screen. On the left side here is the top plan up here. This is the bottom plan, and you get these not equal signs that give you information about what's different between these two plans. And in this case, it's runtime metrics for operators in different parts of the execution. So I really feel like Query Store is a great feature that's going to help you and make your life better as a data professional. Again, Query Store is enabled at the database level, and it stores query plans and all the related performance metrics. You can also force good query plans so that if you find a plan that helps a particular query perform better most of the time, you can actually force SQL Server to use that one. There are some caveats to that, but you can force good query plans. And again, you do get various reports and that show you your performance in a really easy to understand graphical format. So this next category of features that we're going to discuss are features that make troubleshooting data issues easier for you as a SQL Server professional. Now, I'm sure that everyone here, or most everyone here, has seen this error. The dreaded string or binary data would be truncated error. And it's really a pretty unhelpful error. Basically, it just says, I had so much data that I tried to shove into this column and it wouldn't fit. And you say, thank you, SQL Server. Now I have to go dig and figure out where it came from. So there's a little bit of code here on the screen that demonstrates just how to create this error. It's really easy to understand what happens when you have a contrived scenario like this, but as a data professional, you're often looking at a SQL Server agent job that's failed, and you see in the agent history this error about truncation. And you sigh and you maybe roll your eyes and you think, okay, I need to roll up my sleeves. This is an agent job I've never seen before. It runs on a table I don't know anything about. I'm not familiar with this data. And so you end up having to do a lot of digging just to figure out what went wrong. Well, in SQL Server 2019, you get a much better error message. The error message will tell you right down to the column name that had the problem, as well as what value it truncated. This is fantastic. It saves you so much time in troubleshooting data issues. What happened to my data? Why didn't it insert like it was supposed to? So this can be turned on in SQL Server 2017. You have a trace flag there on the slide, 460. This is on by default as long as your database is in compatibility level 150, which is SQL Server 2019. So the next troubleshooting related feature we're going to look at is called temporal, or sometimes system version tables as it's referred to. When this feature is enabled on a table, then you get a history table, and that history table keeps a complete record of updates and deletes that happen by tracking the versions of rows that existed based on a time period. The time range start and time range end values represent the time range during which a particular row existed in your temporal or system version, or I like to say source table. You do have to have a primary key on your temporal table in order to use this feature. It can be used to replace triggers as a means of tracking what happened to your data, what changes took place, and really useful for figuring out when a change occurred. And so it's useful for auditing in some ways. Now, the thing it doesn't give you out of the box is it doesn't tell you who made the change. So I did find this bit.ly link that I've used at another place, another employer, to give us not only what and when, but give you the who. So I would encourage you to check out that link. Well, beyond what I've said so far, why would you use this? Tell you a story. I'm going to call them person A and person B just so I don't offend someone by picking random names. I had a conversation with person A at a previous employer, and at this employer there were various business units, and those business units, from their perspective, they owned their data. They wanted to have access to it. They wanted to be able to manipulate that data, including changing it at will. And I was the DBA. So person A requests this access, and he's using Microsoft Access to keep his data up to date. And he is connecting, or is requesting to connect, Microsoft Access directly to the table. Now, I'm concerned as a data professional because that means there are no application features in place to keep this person from making oops changes. We're at person A's desk and we're talking about this. Person B approaches us. He is a colleague of person A, and we're continuing to discuss what he wants to do. Person B looks at person A's screen and says, hey, person A, this change that you made right here on the screen, and he points to the screen, he said that change is incorrect. Oh, person A says, and he goes into Microsoft Access, does a little typing and fixes it. Meanwhile, as the database administrator standing behind the two of them, I'm thinking, this is exactly why I don't really want to give you this kind of access. But this is a great use case for temporal tables. And in fact, I did put temporal table in place for that table so that we could recover if oops changes were made and we needed to get those rows back. So let's see a demo of temporal tables. I'm going to jump into a version of AdventureWorks and let's create a table here, a backup of a table. And I did mention to you that you have to have a primary key, so that's what I'm doing here. And we get 504 rows. So let's say that you as a business owner, you want to raise all your prices for a particular category. In this case, it's accessories. You want to raise them by 10%. Now, as a good business owner, you send this request down the line, and as a good developer, of course, you write a query beforehand to actually test your change to make sure you're going to get what you want. You are doing that, right? So product name, product number, here's the current list price, and here's the new list price. Yep, this looks like the kind of change I want and that the business owner asked for. So we're going to make a new schema called history to hold the history table. And then we're going to enable an existing table for system versioning. And what this is going to do, we're going to add a couple of columns called sysstart time and sysend time. You do have to use date time too. You have generated always as row start or row end. And then you have a keyword here hidden. That's not required. I do have it here, and what it does is it hides sysstart time and sysend time from query results if you select star from this production.product backup. You do have a constraint that has this default time is a requirement. And then you have a period that indicates what your system and end time, system start and end time are. So we're going to go ahead and run that. We're not quite done though. You actually do have to turn this feature on. And that's what this is going to do. And notice I did give the table a name. You don't have to do that, but if you don't, then you get a SQL Server made up table name that's not really very friendly. So just to show you that there's nothing up my sleeve like a good magician, this table is in fact empty as we expect. So I'm going to go ahead and run this update to update my price. We get 29 rows. So how do I see those rows? Well, one thing you can do is just a standard join between the system table and the history table. I happen to know that these are the products involved, so I'm going to look just for those. And here are those 29 rows you can see that were changed. Here's the previous list price. Here is the list price now. And the system time, sysstart time, sysend time, this is the range, the time range during which this was the price for this product name. So this is a great way to track changes and see when was the price for Sport 100 Helmet Red $34.99. You can answer that question with temporal tables. You can also do it this way, just query the history table directly. You can also use the for system time all syntax. This does a union between your system version table and the history table. So you end up with 533 rows down here in the bottom right. You can see that's the 504 rows we had plus the 29 rows that went into the history table. Now, one thing that I do want to show you is that what changes can you make and what happens to your system table when you make this change. First of all, let's look at the fact that you do have a system version label here and a little different icon for the table. Currently, let me refresh this. Currently, the column is 50 in the history table. and you can see that the column is 50 here in the system table. So I'm going to change that to 100, and that works just beautifully. We refresh this, both locations have their data types updated. Varchar 100. You can also add columns. So if you add a column to your system version or temporal table, it does go into the history table as well. So now I have a column just called meaningless. Going to do a little bit of cleanup here, but part of why I'm going to show you this is this statement here. You do have to, in some cases, turn off system versioning in order to make some changes actually work. And then you turn system versioning back on in order to turn your temporal table back to the way that it was. So that's temporal tables, and I really feel like this gives you a good way to have more troubleshooting features at your fingertips as a data professional. So the next category is permission enhancements that are going to make your life a little more simple. These enhancements showed up in SQL Server 2019. You have connect any database, and this simply just grants the connect permission to a login to every database on the SQL Server. You can combine this with other permissions like grant view server state, and then what that's going to do is give a login the ability to monitor performance via the dynamic management views without being granted access to the actual data in the databases. You can also combine this with select all securables. And what this is great for is providing report writers or business users who might be power users the ability to read or select data from any database in the system. And it's much simpler and easier to do this than go database by database in the case that you are actually intending to grant them access to all the databases. So these are just some simpler, quicker ways to grant some permissions. The next category that we're going to look at is T-SQL enhancements, things that will make your life easier and simpler from a T-SQL perspective. So here we have a number of things on the slide. We have drop if exists, JSON format support, alter table with online equals on. We have some enhancements in terms of inline specifications for indexes and some new string functions. So I'm going to go ahead and just demo these changes for you so you can kind of see what they are about. I'm going to demo a few of them. The alter table online won't be one of them, so I'll just tell you a little bit about that one. You can use this to make column data type changes and other things like column length, precision, and sparseness, all of those things while the table actually remains online. It does use up or can use up a fair amount of transaction lock, so be aware of that. But at least you don't have to take downtime necessarily to make a table change using this feature. So drop if exists. I'm going to get into this DBA utility database. I'm just going to create a table. And a previous method that you might use for figuring out does a table exist before you're going to drop it is seen here. It's 7 lines long. It works perfectly. There's nothing wrong with it. It's just a lot to have to type. And you might do this if you were doing SQL Server or T-SQL promotions from dev QA production. You want to see if something is already there, because if you try to create a table twice, you're going to get an error the second time. So this code works, but what if you could do it in one line? Wouldn't that be pretty sweet? Drop table if exists, my test table. Boom, it's gone. One line, a lot less typing and a lot less stuff to think about. You can do this also with stored procedures. So drop procedure if exists, and now if it was there, that procedure is gone. Here's create or alter for stored procedures. So you might use this instead of drop and recreate, especially because you can run into some permissions issues or errors if you drop a stored procedure and then create it with a new definition. This allows you to create a procedure if it doesn't exist or change it if it's already there. So in this case, I'm creating a procedure that just does something really simple, and you can see that I get 5 rows back. Now, if I change the inner definition of the stored procedure here, where I'm going to select top 50, it's just going to alter the existing procedure to match this definition inside. So when I call it this time, I get back 50 rows. So inline specifications for indexes. I really like this feature as a person who, as a developer, as a person who might be creating tables. I think this is really useful. You can see or have some sort of an idea of what indexes you might need based on what you know about the application and how you're going to build it. And this gives you a nice, easy way to add indexes right within the create table. You don't have to create the table and then do create non-clustered index name on DBO table name and a long syntax. Instead, you can just do what you have right here, index name, the columns, and in this case, because I'm showing you can do as a filtered index, we do have a where clause. Well, you can also do this for multi-column. It's not just single column indexes, and I'll quickly show you that. You can do multi-column unique indexes using this. So I have index ix1 unique non-clustered on columns 1 and 2. This works beautifully. I wonder if it works for clustered indexes. So I tried it, and yes, you can actually create a unique clustered index using this inline feature. Next, I'm going to talk about concat and cat with separator. I do have a blog post on that you can read through if you like. So to join some data together in a string, you have a couple of different options. Here you're going to use plus and a space plus your column name, space plus column name until you build this mailing name. With concat, you can you don't have to use the plus over and over again. You can just specify, you can leave that out and use column name and your separator. But that's not the only reason that you should use concat. In this case, you actually get different results. The traditional way of doing concatenation is going to leave you with nulls in the mailing name if you have any null in a column that you're trying to join together with some other column. So in this case, I only get one name. That's not a very useful mailing name column. With concat, if you have a null in any of the columns, that value simply is left out. So in cases here where we don't have a middle name, you get the person's first and last name. So I think this is a great feature, a great enhancement to how you can do concat. Concat with separator looks like this. And in this case, you do the separator one time, and then you just have your list of columns. So this is even simpler. It's even shorter to do, and you get the same results as you do with the concat function. Let's come back to the slides. So those are T-SQL features that I think are going to make your life better as a data professional. That you can find these only in modern versions of SQL Server. So the next or last category we're going to talk about is high availability and disaster recovery. What exactly is high availability? What do we mean when we say disaster recovery? Well, high availability refers to being certain that your application is accessible and working properly as much as possible. High availability has to do with maintaining uptime. Examples of things that might be part of high availability planning are network path redundancy to storage, or having multiple computers up and running to handle a workload. For example, you might have multiple web servers behind a load balancer or multiple redundant copies of data for a SQL server. And in the case of SQL Server, there are methods to keep an entire instance available, like SQL Server failover clustering. And there are methods to ensure that individual databases or groups of databases stay online, like in always-on availability groups. Your disaster recovery is the plan that you use to keep your applications up and running in the event of the loss of your primary data center. So, for example, if your primary data center happens to be in that building on the screen that's surrounded by water, you might want to be sure you have a disaster recovery plan. If the river floods, you might lose access to your primary data center. Your employees can't get into the building. Uh, Beyond that, the equipment inside that building is probably or potentially wet. In the case of computers, it's destroyed and non-functional. So your computer infrastructure needs to be as accessible as possible, as much of the time as possible. So unlike the house in the boat, uh, you're going to have a hard time, or the house in the screen, you're going to have a hard time getting to that and without a boat. So here at the top right are some links to talk about or give you some information about availability groups. They did appear in SQL Server 2012. Please, please, please do not use them on SQL Server 2012. Try it on newer versions because there have been a lot of enhancements. There is a bit.ly link to an MS Docs there that tells you information about what is an always-on availability group if you want to read that or look at that later. I also have a link to a post there on my blog called My Availability Group Database Isn't Synchronizing, just giving you some basic things to look at if you have that particular issue with your availability group. The always-on availability groups feature is built on Windows Server failover clustering. And a Windows cluster is just a logical group of Windows machines that work together to support one or more applications. In the depiction on the slide, we have multiple machines, nodes 1 through 5, that are all in a Windows Server failover cluster. And we have a primary replica there on the left and secondary replicas to the right. And those groups of databases are in an availability group, which is just a container. And in this case, it's just called myAG. It is recommended that you have what's called an availability group listener, and that's not depicted because I had a really difficult time just finding something that would give me this much information to show you. But an availability group listener is basically serves as the same function as a cluster network name and a failover cluster instance. It's just a named connection that your application would use to point to in order to make a connection to the SQL Server. And in this case, the listener and the availability group in Windows Server failover components know at any moment which node is called the primary or the one that's accepting read and write activity. So you connect to the listener and it connects you to the correct node or computer. SQL Server can automatically fail over the entire group of databases from the current primary to one of the secondary nodes in the event of a server restart or like an unexpected issue that causes some sort of an outage. So this is really helpful when applications depend on not a single database, but often an entire group. The entire group of databases move together in an availability group. Also, unlike a SQL Server failover cluster, which requires shared storage and then by default leaves you with a single point of failure, availability groups allow for data movement between the participating nodes so that each node's own storage has a copy of the data. If you're using something like a SAN for storage, you still have a single point of failure unless you talk to your SAN or your storage administrator and make sure that you have a copy somewhere else for disaster recovery. So the movement of the data between the primary replica and the secondary replica actually sets us up to talk about the next thing, which is using availability groups for disaster recovery. Disaster recovery to a remote location using availability groups, I feel like is relatively easy to do with always on availability groups. You don't have to set up log shipping for a bunch of databases. There's no need to try to set up transactional replication. And in that case, you actually have to be sure that your table design will support replication, meaning you have to have a primary key. And I've seen lots of databases in the wild, and I was shocked to find that most of them, or a lot of them, had tables with no primary key. So there are certain things that just have to be in place in order to use other options. A common way to set up disaster recovery using availability groups is what's called a multi-subnet failover cluster. And in this particular scenario, you would add one or more nodes in a remote location to an existing Windows failover cluster. So in our example, we have a primary data center here on the left and two nodes, we have synchronization happening between these two nodes on the left. And then we have two more computers. All four are part of the same Windows Server failover cluster. The nodes in the disaster recovery most likely are going to have a different range of IP addresses. The availability group listener then has two IPs that it could use. And so there are two settings that you really have to pay attention to and research and understand and know your application and how it works, which are register all providers IP and then multi-subnet failover. If your application does not support multi-subnet failover, then you want to change register all providers IP to 0. You want to turn it off. It's on by default. So multi-subnet failover equals true would allow the system to the client to get all the IP addresses that are available for the listener and connect to whichever one is active. If your system doesn't support that, then when it tries to get all the IP addresses, some of the client connections are going to try to connect to the disaster recovery IP for your listener. And that's the only IP address they're going to attempt. When that's not online, the connection just fails and you have timeouts. You don't want that, obviously. So really do your research about whether your application supports multi-subnet failover and pay attention to this register provider all IP setting. One last thing that about this feature of SQL Server that I really feel like makes your life better is the built-in ability to make databases in the availability group readable. This makes them available for as resources a query over in your secondary nodes and makes a great scenario for reporting workloads. Reporting workloads are notoriously resource intensive, and if you have a huge reporting workload, you might not want that running on your primary. And this allows you to make that shift. You can also extend that by using what's called read-only routing. And what that does is it allows all the connections that are going to be reporting use the availability group listener for its connection. And through coordination under the covers, the SQL Server with a change in the connection string will move your queries that are read-only over to a secondary. So we've talked a lot about availability groups and mentioned a number of things. Here's a slide that just kind of summarizes some of those positive things that I feel like you're going to get from always on availability groups. Redundant copies of SQL Server data. Something I didn't mention is that fourth bullet point, automatic page repair from a secondary. So if a primary realizes that there's a suspect page or a broken page, a problem with the data there, it can, under certain circumstances, get a correct copy of that page from the secondary, and it does it automatically, no intervention from you. Accelerated database recovery is the next feature in the HADR, high availability disaster recovery concept that we're going to talk about. This particular feature uses something called a persisted version store in each database, and it enables SQL Server to roll back faster than using the traditional transaction log, and it does this by what's called a logical revert. The persisted version store works in a similar fashion to read committed snapshot isolation for those who would be familiar with that. It keeps a previous version of a row so that if a transaction is aborted, SQL Server can simply replace the uncommitted row change with the previous version of the row. So much quicker than reading through the transaction log in a serial matter, redoing and undoing or rolling back transactions. Where this might be helpful, for example, on the slide, we're showing some email addresses, and let's say that your company wants to change the format to firstname.lastname@adventureworks.com. And your developers create a SQL query that does this. They've tested it. They tell you it works. They run it in production, or they hand it to the DBA to run, and it's really taking a long time, and nobody really understands what's going on or why it's still running. And someone thinks to themselves, well, I know that SQL Server does crash recovery if you restart it. So let's do that and see if we can just kill this and get back online quickly. So someone restarts SQL Server, and anticipating that the SQL Server is going to come up pretty quickly, but 2, 3, 4, 5 minutes goes by. All the other databases are online, but the one that you're trying to change, where you're previously trying to change the email address, is still not online. If you were on SQL Server 2019 and accelerated database recovery is there by default, this online process just happens so much faster because you don't have to read serially, or the SQL Server doesn't have to read serially through the transaction log to figure out what the consistent state is. It uses this persisted version store to simply do a revert. So how can you discover some of this information for yourself? How do you find SQL Server features that are going to make your life better? Well, there are a couple of links at Microsoft that give you information about SQL Server 2016 and above. And then that second link will show you everything, I believe it's 2005 to 2014. MS SQL Tips, one of my favorite websites, has a number of articles there and tip blogs that they will share that have information about new features. You have companies like Pythian that when a new SQL Server version comes out, they will write a blog post about the things that they find that they feel like you want to know about. Really want to hone in on and emphasize that you should look at the 2 links at the bottom from Aaron Bertrand, because in those links, Aaron talks about how he finds SQL Server features that Microsoft maybe isn't even talking about. And so those are great ways. He goes through great ways to find things that aren't being advertised. There's some bonus material, things that could go into the presentation at some point, or just things that I knew were features that do make life better in some cases, but didn't have time for them today. In-memory OLTP. In some cases, this can provide improvement for workloads. For people in the BI space, reporting space, who might be into machine learning services, you have Python and R integration that is available. You have a number of security enhancements in modern versions of SQL Server, like backup encryption and the other things listed there on the slide. Column store indexes, I believe, are a great feature, again, in the right case. They did appear in SQL Server 2012. Use them in later versions because they have received a lot of enhancements that make them better to use, but great for tables where the workload is primarily or only read for reporting information. So in summary, we've talked about the following categories and features. We looked at performance. We talked about that collection of features called intelligent query processing. I talked through Query Store and showed you some graphs and the information that is available to you in Query Store that helps you with performance and performance troubleshooting. We looked at the troubleshooting category, where I showed you some things that help you understand your data better and troubleshoot data issues. We talked about permissions and how you can more easily assign permissions, particularly for things like read-only. We looked at a number of T-SQL enhancements that I feel like make your life better and simpler by enabling you to write less T-SQL and achieve the same effect. And then we looked at high availability and disaster recovery, where we talked about availability groups and all the advantages and positives that there might be with that for you, and looked at also accelerated database recovery. Well, that's my presentation, and I really appreciate you attending. If there are any questions, we can talk about those. And here is my contact information.
Yeah!